Hey, good afternoon. How's everybody?
Good afternoon, Professor.
Hey, good afternoon, Sarah.
Good afternoon,
Good
Professor.
afternoon, Jimena, Mohammed. Well, three people. I mean, yesterday we had three people at the beginning. Uh, Still the same thing, but I have at least six people currently signed in to the discussion board. So I'm hoping the rest of the class will be joining shortly. So um, let me share my screen. All right. Okay. Okay. Remember yesterday we finished um, talking about the natural log. Uh, the steps of derivation, right? And then, uh, uh, of course, you all understand that the natural log is the log with base e, right? Log using e, Euler's number, as the base. And that is uh, the reason we talked about that. And it was, so for some of you, it's way, way above your level. I mean, if you don't even have math, if you haven't even taken math 206, um, and I'm afraid, the public school system in New York City and in the United States in general, at large. I mean, math doesn't progress any further than just eighth grade. Eighth grade. Generally, even college students. There's a wide variance. There are some students who went to private schools or even public schools, but there are very good public schools as well who learned, at least maybe not natural Euler's number or natural log, but if you have gone through, K through 12 system, by the end of the high school, at least um, you have picked up, you have learned trigonometry, at least basics, calculus and everything. But these things are completely foreign, something that they never heard of, for most New York City public high school graduates, and that is that's very uh, sad. Uh, but you have to face it at some point, right? And if you never heard of it before, we talked about it yesterday. And the reason we talked about it is because of this formula. Now, so uh, our we have we have so far we have so far uh, derived the formulas for three other variables. Remember, starting from starting from this base formula, right, for compounding. Here, base formula for compounding, right? And what did I say? There are four variables. There are four variables in this equation, right? That means there can be four questions. Why? Uh, because each variable can be the unknown, right? The compounding formula, in compounding formula, future value is the unknown, but the rest of them, P and R and N, are all known. And in discounting, if principal is the unknown, you solve this equation for P. So then that is the formula for discounting. I mean, we can easily, because I've been telling you, every No matter what, no matter how complex, all equations can be solved as long as you can identify z equals x times y structure, right? Then x is clearly, we can, so it doesn't present to you, I mean, this is a very easy example because it's already presenting itself to you as z equals x times y structure, right? But not everything is that simple. Not everything is that, readily amenable to that z equals x times y structure. But that's your job. I mean, that's your responsibility. If the equation is complex, equation is a more complex structure, then you have to make it, you have to simplify it, you have to make it as simple as possible until it is brought down to visibly identifiable as z equals x times y. And once that is done, you can easily solve for x, right? So in this case, we did that. And next, another possible question is, what is the interest rate, right? Meaning you have target future value, you have present value, right? You have principal, you have time. So in other words, you have $10,000 today, and you want to grow it to $30,000 in 5 years. So you have, then what should be the interest rate? So you have this, P is known, future value, the target future value is known, 5 years is known, then the only unknown is R, the rate. So how do we solve for that? And we talked about that, so almost, it took one day, and this took one day. It took so much time. Now, I mean, just talking about the natural log, Euler's number and natural log, to almost, it took almost, 2 days. But to do that, we had to go through, the rules of power function, the rules of power, exponents, right? And then, rules of logarithm. Now, so here, this time, n is the unknown. So you have the target future value. You know what future value is. In other words, in 5 years, you want to have, you don't know 5 years. I mean, your target future value is 50,000, right? Exactly like the scenario, right? Your target future value is 30,000. You have currently $10,000. And the interest rate is this. And compounding is annual, so we don't have to worry about compounding, the frequency, compounding frequency. But it doesn't hurt. We can still adjust APR by m, because it doesn't hurt, because anything divided by 1 is still a self. So then our question is, with interest rate given and with the principal given and target future value known, the only unknown is how long will it take? How many years will it take? Right? So here, and so n is the unknown. Okay. So some people might say, Professor, isn't that t? I mean, isn't n different? Yes, n is basically t times m, right? N is t times m, isn't that right? N is the actual number of compounding. So if the compounding frequency per year is 4, in other words, if the compounding is quarterly, then over 5 years there will be 20 compoundings, right? That's n. But if the compounding is annual, there's only one compounding per year. So over 5 years, it will still be 5. N is 5 in the case. In other words, when compounding frequency is 1, there's no difference between APR and R, the periodic rate, and there's no difference between N and T, because, N is M times T. M times T is just 5, right? So it doesn't really matter when compounding frequency is 1. It will matter when compounding frequency is greater than 1. Okay? Now, so if to find n, right? To find n, and again, R and N are generic notation for rate and number of periods, right? Number of compounding periods, total number of compounding periods, right? Because R, what is R? Anybody? I mean, what is R? We redefined R as what? Because APR is annual rate, then R is defined as what? Anybody? Can anybody okay, we have Christopher. Are you there, Christopher? Christopher, I would have to assume you're absent because your Christopher, your connection. I mean, your this is your data transfer activity is high, but Mohammed, what do you mean not sure? You mean you don't know, right? Mohammed, are you there? What do you mean not sure? Okay. It's just a matter of going back. It's just a matter of going back. I mean, you don't even have to. It's a matter of going back, review, study the past lectures. The videos are all, and it's not even the videos are all, update every day. I mean, again, I'm telling you over and over, this is not today's class, right? Today's class is actually already, we are behind. Today's class, today's lecture is in topic 3, right? And these are today's, and these must be yesterday's from yesterday, and right? So at least, okay, you can go back to August 4, today's lecture, financial statements, part 3, ratio analysis, part 1. So, financial statements, part 3, ratio analysis, part 1. These are today's lecture. And you must be up all the way, you must be caught up all the way here, right? All the way up to this point. Okay? So we are, so we are like, a week behind, right? And I've been telling you, our class is not behind. This review session is behind. And collaborate session is only a review, reflection, right? So think about it. We are only talking about these, this topic. That was last available July 31st. So actually, these topics were like July 31st was what? Must be July 31st was Saturday. So obviously, the this was 5 days, because these videos are available for 5 days. So that was actually, July 26th topic. These were July 26th topic. You understand? We are even, this collaboration session is even, more than a week behind. And that means you should have studied these videos already on July 26th. And they were available until July 31st, so you could have watched it 5 times, at least, once a day and 5 times. So it shouldn't be something like a completely, you shouldn't be a total stranger to that. And besides, every day I update, I'm updating. I have, you see, I have yesterday's recording here. The day before yesterday, that was Monday, yesterday. So why don't you, I mean, that's the second chance you get, right? And then you don't even have to go to we defined, and here in this, and I gave you this material, read, the PDF reader, right? Not only Excel file, but also the PDF
But
reader.
like it definitely like I love arguing with him. Like I hate it, but like I love it at the same time. It's like so.
Are you speaking? Hello? Are you speaking to me?
Oh, sorry.
Who was that? Were you speaking to me? You said you hate it and you love it, and
No. I was talking to my mom. Sorry.
your microphone clearly, your microphone was on. And here, if you read it, it says clearly here what R is, right? And we also talked about that. Right in this Excel file, what is R? R is one APR over M. What does that mean? You are making adjustment. You're making adjustment to the APR, right? By the compounding frequency per year, right? And also here it says clearly, why is it like this? It says clearly here, right? APR is periodic rate. So think about it. I mean, this is just a matter of, interpreting. It's just a matter of, someone with, average level of, reading comprehension ability. I mean, periodic rate. What does that mean? Every period, that's the rate that applies to every compounding period. It's not that difficult to understand. I mean, math tells it very clearly. APR divided by M. And what is M? M is compounding frequency per year. So if M is 4, right, it's quarterly compounding, 4 times a year. M is 1, just annual compounding, once a year. If M is 2, right, twice a year. So semi-annual compounding. 365, right? If it is 12, a monthly compounding. If M is 365, daily compounding. So if compounding is 4 times a year, then every time, what is the actual rate? What is the actual rate that gets compounded? And then, of course, then you will have to divide this by 4. Isn't it right? If compounding is just once, it will just be still 8%. If compounding is twice a year, and every 6 months, if APR is 3%, divide this by, so this is nothing difficult. And if you're saying, I don't know, not sure, what does that only mean? You didn't study. You just, you're not pouring yourself into it, right? And I mentioned this before, and I quoted Winston Churchill, right? That's the speech from Winston Churchill gave speech, to the British people, when he was, when he was, elected prime minister. Actually, in a British, system, the leader of the ruling party automatically assumes, uh, the office of prime minister. So that means, in the election, um, his party won. And before him, I think it was Disraeli or Disraeli, a weak leader who was trying to make peace with Hitler in before World War II. But that dialogue didn't, peace talk didn't go well. Disraeli came back. Um, they had like non-aggression agreement, but those things are nothing but piece of paper. And then so the Israelis party lost, and Winston Churchill's party won. So Winston Churchill became the wartime prime minister, and he gave speech to his people that he can't guarantee anything. All he can guarantee to his people are blood, toil, sweat, and tears. And that means that's the kind of fight you have to give to win. You have to shed blood. I mean, you have to be, you have to be willing to do the toil, right? You should be, you should shed sweat. You should shed tears. That means it's going to be a painful process, painful road, 30 painful road. And studying is just the same thing. There's no studying that is enjoyable. I mean, if you can enjoy it, that's fine. I mean, someone like Einstein, a genius would enjoy studying quantum physics. But if you're not, if you're just an average person, right? Studying is obviously not a pleasurable, enjoyable activity. It's something that requires maybe not blood, but toil, definitely. So toil, sweat, and tears. And that's the mindset, a sharp mindset. That's what is required, right? The mindset that is willing to, take up, willing to fight the fight. But then, with a, mindset that just, is laid back and, not willing to make any sacrifices, you can't go far, right? If you pour your soul into this, right? If you pour your sweat and tears, and if you pour your toil into this, then it will never betray you. You will get, at the end of the semester, you get A, or at least something decent, A minus or B plus, at least, depending on how much, toil, sweat, and tears you put into it. You gotta put your soul into it, really. But if you do nothing like that, just if you just want to get by, then you don't get the obviously there's no good grade waiting for you. right? That mind, that, the mind of a soldier, in a combat, that mindset of the soldier is what is required. Willing to fight the fight, even if even if your head is bashed, or the mind, the mindset of a soldier in a combat. What do you think it's like? It's always like, if either of us has to die, it's better be the enemy, not me, right? But think about it. If you were to survive, what do you have to do? You have to kill the enemy, whether you like it or not. It's better be the enemy than you. Would it be better, if it was you lying there dead? So you have that kind of mentality. But that's what, all the successful people, success doesn't come on a flower bed. If you think about, walking on a flower bed, that's not the road to success. The road to success is thorny. You have to fight it. So I don't know how much time you spend, studying these materials, but at least if you are, if you are thinking of it like a battle, right? If you think of it like a battle, then you would have that mindset of a soldier. A fighter. A mindset of a fighter. That's what is required. So I said R is called the periodic rate, right? Which is not a difficult thing. And N, then what is N? N is the actual number of compounding, because it's T times M. Remember? It's T times M. And this is called abstract thinking. And if you are not incapable of abstract thinking, and what that means is, some people always tell me, "Oh, professor, I don't understand. Give me some actual examples." By actual example, what they mean is, give some name, like, and give some example, like, Jack and Jane went to Apple store, and Jack wants to buy iPhone 12. Jane wants to buy iPad, and iPhone is $1,200, $11,000. iPad is $12,000. Their budget constraint is $2,000. What should they do? I mean, they want this kind of verbiage. If you need such a verbiage, then your brain is still immature. Because that's an example that works in elementary school. Do we need Jack and Jane? Do we need iPhone 12 or iPad? Do we need, these words? You don't have to, right? All you need is, we have product X and Y, right? Product X is 11,000. Product Y is 1,000. Product X is 1.1 thousand or 1100. Product Y is 1000. Our budget constraint is 2000. Something like this. In other words, algebraic model is abstract thinking. You don't, because people who need verbiage, like Jack and Jane, iPhone and iPad, iPhone 12 and iPad. What if the situation changes? I mean, we have to give name to, in another problem. And now the name changes to Steve and Jill. The name of the objects now should change to something like Dell Computer and Hewlett Packard. Wouldn't that be too tedious? And it's not very efficient, right? Because if you have to change the scenario every time, but it's the same narrative, right? Why can't we just call it X and Y? We don't need name of the people, right? X and Y, just give it, we use the variable like that and just give it the data, right? Give it the constraint. Or that's what a mature brain does, and that's what a mature brain can process, right? So I gave you R is APR divided by M. We defined what M is. APR is obviously from its acronym. From the acronym is obvious. What else can it be? It's annual percentage rate. So that kind of acronym, is it so difficult? Huh? And we defined M as compounding frequency per year, right? How many times the compounding happens per year. Then APR divided by M, it should be obvious without verbal explanation. It should be obvious, right? It should be obvious. Without such name as periodic rate, it should be obvious. The math tells you what it means. Annual rate divided by compounding frequency. Oh, then it's the actual rate that gets, applied every compounding period, right? But the reason we are doing this is to eliminate that verbiage, because the verbiage takes time, right? I can't explain to you every time this is the actual rate that gets applied every compounding period, or every month, or every quarter, or to get rid of that verbiage and the verb. So algebra is like one generic rule that can be applied to every situation, right? In other words, we don't need to handle this separately. We have one formula. Just, we have a single algebra that can take care of everything, right? And by solving this once, and then we can copy and paste it, right? And this is the benefit of algebraic modeling, and this is what we have been doing. And so I was asking you, what is R? And from even that question, you said, I don't know, I'm not sure. All this time, how many days has it been? We've been working on this topic alone for almost a week. And it's very disappointing if I have to explain over and over again every day what R is, If I have, and that this is not just the first time, because as I said, this is not our main lecture. The main lecture, this one was already done on July 26th. And if you studied that video, you could have studied even 5 times, just watching it even, once a day. You could have, watched it 5 times before it became inactive. And after that, we've been still, we've been dwelling on this topic for almost a week. And you're still saying, if you're saying still that you don't know, then there isn't much I can do anymore, right? And the daily recordings are, daily session recordings are updated daily on both, Blackboard and YouTube. It's just a matter of, finding it, and it's not difficult to find. You come to a Blackboard, it's there in the topics folder, and if you go to YouTube, it's there. Right? How unmotivated do you have to be not to do any of those? Okay, so here, I'm not going to go over this again, So here we know this time n is the unknown, right? N is the unknown, and we cannot isolate n, because look, how many times did I tell you the key to solving any equation is to identify z equals x times y format, right? Z equals x times y pattern. And that pattern is here, obvious. This is z. This is x. And this whole thing is y. Okay? But then, think about it. So, n is not y, right? This 1 plus r raised to n is y. So then we cannot, it's obvious, we cannot directly isolate n. So what do we need to do? We will have to do whatever we can. And what we can is isolating y, right? So we isolate y like this. And then from here, that's where the properties of logarithm comes in. And one of the and most interesting properties of logarithm is that this exponent, right? Exponent can be brought down like a coefficient. So in other words, it's base 10 log of 10 to the 6th power. You can simply turn it into a 6 times base 10 log of 10. And of course, if it is base 10 log of 10, then that's 1. But we don't we don't take common log of this. We cannot take common log of this because we can do that, but again, it will be handled by it will be calculated by the computer anyway. It can, but normally you taking common log of normally you take common log of the numbers that are powers of 10. Okay, you take common log of the numbers that are powers of 10. If it is not powers of 10, a power of 10, generally don't take, common log because it's hard to visualize what it might be. So you don't take binary log, and we don't know what this number is. We don't know what R is. We know, I'm sorry, because when N is the unknown, R is known, everything else is known. So this is known, right? R is known. So it may be something like, it may be a number like 1.025 or something like this, right? But then the question is, we cannot take common log of this. I mean, as I said, yes, we can, but it's usually common log. As I said, you don't take common log of something other than powers of 10. And even though you can take common log, it's not it's not easy. It's not, and even though you can take binary log, it's not easy. So what do? You take the natural log, because I told you yesterday, natural log can be the base. I mean, Euler's number can be the base of log for any number, right? Since Euler's number is, based on a number that is slightly greater than 1, right? Slightly greater than 1. It can be the base for any. I told you, 1 cannot be the base of any log, right? 1 cannot be the base of log. Why? Because 1, I've been telling you, no matter what you do, raise 1 to any power. 1 squared is still 1. 1 cubed is still 1. You raise 1 to 10 power, you raise still 10. 10, still 1. 1 times 1 times 1 times 1 times, no matter what, it's still 1. So 1 cannot be the base of any log, right? But something that is slightly greater than 1, like 1.0000000, infinitely 0, something like that, a number that is slightly greater than 1. And of course, Euler's number is Euler's number is 2.718 and something like that, 2.871 something. It goes on forever, but that's the gross 1 plus Euler's number. It's the 1 plus 1 plus 1 over 1 plus infinity, right? So it's 1 plus and so Euler's number is actually 1.000001 infinitely 0 and 1, so slightly greater than 1 raised to infinity. And so because there is it contains already 1 in it, the net return, to find net return, you must subtract 1. So it will be eventually 1.87 something. But the idea is it can be the base for any log. So that's why we use natural log. So we take the natural log here on the right-hand side. And why do we do that? Because of this property of log, right? You can, when you take the log, the exponent can be brought down. The exponent can be brought down like the coefficient. And to use that property, we take the natural log. And when we take log, to take advantage of that property, and we have to take natural log because natural log can be the base of natural log is based on Euler's number, which can be the base for any number. And when you take natural log here, I mean, I've been telling you over and over, this is an equation because there is an equality sign between the left-hand side and the right-hand side, right? That means left-hand side is equal to the right-hand side. Then if we do something to the right-hand side, we must do the same to the left-hand side. You understand? That's the only way that equality can hold, right? You do only one, you do something to only one side, then it's like a balance, right? Scale imbalance, right? And if you do something on one side of the scale, the other something, it's not gonna hold, right? It will, one side will go down, or the other side, and the other side will go up. So it's not equal. So you have to do the same thing. And when you do the same thing, right? And then a very good, this is why we take the log, and then n can be brought down like a coefficient, which means now this is z equals x times y, z equals x times y structure. Now this is z equals x times. You understand? Now, let's see. Christopher, are you there? Christopher? I'll have to assume Christopher's not. Okay, Christopher. Oh, good, you're there. How come you never, Christopher, can you tell me, do you identify z equals x times y structure here? Hmm? Yes or no? I mean, don't procrastinate. Don't delay your response more than 5 seconds. Do you identify z equals x times y structure here? Do you? Okay, what the, Mohammed, okay, Christopher cannot, okay, but Christopher, please answer, yes or no. You can type it into the box, chat box. Okay, Mohammed, Mohammed,
Yeah. Yeah, so in this case the ln would be the z, and then the
ln
n
is
would be
z,
the x. Yeah.
n would be the x, n would
No,
be
no.
the x, okay.
I was talking about the, yes, n would be the x and the r would be the y.
R?
Yeah.
No, 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 no. If n is the x, if n is the x, and what is z? What is z? You said ln? ln is
Yeah.
nothing. ln is not quantity. ln is only a symbol. Natural log is a symbol. Okay? It's not actual numerical value.
Hmm.
Okay? In other words, just like ln is no, natural log is. Say that again. Is that Mohammed? Is that Mohammed? Who said a while ago? Sarah? Was it you, Sarah?
Yes, Professor, may I?
Yeah, sure, yeah. Go on. Let me switch to Sarah. So which one is x? I mean, which one is z? Do you see z
Z,
equals x times y structure here? What is z? Which one is z?
Z is the natural log of future value divided by the present value.
Yes, that's z. That's z. That's z, the whole thing. And then y is?
The natural log of 1 plus r.
Yes, that's y. So we have this. Okay, Sarah, so you got, that was a very good answer. You got 0.5 for that. Okay, so then since x is the unknown, in other words, our n is the unknown, right? So to solve for n, we do, it's simple, x is to solve for x, what do? I've been telling you, z divided by y. I mean, no matter how complex the equation may look, this is not even complex because it's already presenting itself in the plain eye, right in your face, in plain eye. It's already z. This whole thing is z. It's already z equals x times y structure, right? But you will encounter, I mean, as you study economics and finance, or physics, or math, statistics, you encounter a lot of a huge number of very complex equations. But the point is, I mean, no formula is in a disorganized. I mean, if it is very long, very complex, that's not obviously a good formula. It's not the final form. The ultimate form will have to be crystallized. In other words, it has to be reduced and simplified down to the simplest form, right? And that process, reducing it and simplifying it to the down to the simplest form, through that process, you have to bring it down to z equals x times y structure. Once that z equals x times y structure is identified, then you can solve for anything, right? So here, okay, that's x, this is z, this is y. So we got the formula for n. Okay, so now let's apply this to our example. Okay, so here we had this example before, right? And in your homework, if you got your homeworks back, you have you have seen my comment. And people who haven't put a thick borderline around the model, you got like minus 2%, right, out of your whatever you got. So don't forget to put a thick border around it. It doesn't have to be a red border. I just use red border to emphasize. But you can usually it is black, right? The border line color is black usually. So if you just highlight the area and click on the thick outside border, then you'll get it. So here we have this. So let's think about this. We know the answer is 5 already because we have it's the same scenario, right? Previously we didn't know the APR. We found the APR, right, by using that formula. This time we don't know. This is the unknown, but because it's the same scenario, we know it. But we want to find it by the formula. So, and since this is annual compounding, right? We don't need to make any adjustment to the formula, right? Annual, since this is annual, all you need to do is natural log of FV over T over natural log of 1 plus R. Okay, enter. Yes, you got 5. Now this time, the compounding frequency is 4. The compounding frequency is 4. And that's why we got, that means, compounding is quarterly. And this is not right, because if you do it like this, think about it. 5.65, that's the quarterly rate, right? It's the quarterly, in other words, that's the periodic rate. So the reason this happened was because this compounding frequency was not taken into consideration. So taking that compounding frequency into consideration, then think about it. It is, Fe over P over 1 minus T, 1 divided by T, and the T, the adjustment is made, and then the whole thing, so that will give you 5.2, will give you 5 point something, the quarterly rate. But this cell is asking for APR, right? So how do you convert quarterly rate into annual rate? Anybody? Can anybody tell me? How do you convert quarterly rate into annual rate? Anyone? This is a very easy question. And I have only 4 people here. Jimena, are you here, Jimena?
I'm here.
Hey, Jimena, can you tell me how to convert quarterly rate into annual rate? Five seconds are up. This is not the Maricel. Are you here, Maricel? 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 Maricel, you're not. Okay. Mohammed, I'll give you another chance. Mohammed, I see your connection is very weak. It looks like but Mohammed, are you there? Can you hear me? Mohammed. Okay. I would assume that you are not well connected. Sarah, are you there, Sarah?
Yes, Professor.
Okay, Sarah, can you help me out here? How do you convert? Okay, Mohammed, I can see your connection is very poor. Sarah, so how do you convert quarterly rate into annual rate? Okay, Maricel, yeah, you could have answered also in the chat, but maybe I couldn't check. Okay, I see that there. Now you just did that now. Okay, so I'm sorry, Sarah. So the question is still valid. How do you convert quarterly rate into annual rate?
Actually, I don't know, Professor. Sorry.
Oh, come on, this is an easy question. So it's really a point giver.
Divided to 4, maybe.
Look,
No.
no. That's the opposite. Think about it. You turn annual rate into quarterly rate by dividing it by 4. Isn't it right?
No, maybe 4.
Listen. What if you divide annual rate by 4, then it is quarterly rate. Because think about it. If annual rate is 10%, right? Every quarter, what should be the rate? You divide it by 4, then that's the quarterly rate. Isn't it right?
Yes.
Yes, but then the logic is, my question was, how do you convert quarterly rate to annual rate? Did you understand the question?
Yes, maybe like times 4, maybe.
Yeah, what times 4? What times 4?
The annual times 4.
No, why annual times 4? If you if you do annual times 4, then that will be 4-year rate for 4 years. It's just a simple logic. If you got quarterly rate by dividing annual rate by 4, then it's the reverse process. You multiply you multiply the quarterly rate by 4, then it will get back to the annual rate. Isn't it right?
Yes.
No, that's like, if z divided by y is x, then how do you get to z? Z equals x times y, right? If 3 is, how do you get to 3? 3 is 12 divided by 4. Then how do you get back to 12? 4 times 3, right? 3 times 4. So it's just the very common sense logic, right? This is not this is not hard math. It's just common sense logic. So think about it. What we did here, this gave you this gave you the quarterly rate. So if that gave you the quarterly rate, then you multiply that by 4, then it will take you back to APR. So then where is 4? We don't enter 4 manually. We don't enter manually number there, because I've been warning you, that's called hard coding. If you do hard coding, it cannot be reused. It cannot be reused, right? So it has to be always soft coding. And so where would 4 be? 4 is actually in E27, and we cannot click it in because it is hidden under this expanded formula. So then in that case, I will have to type in E27, which I'm sure contains 4 there. There you go. Then we got to this. Okay. Now I'll make it equal to C27. So look, here's the, you might wonder, oh, previously the APR is the same scenario, but the APR was 24.57. How come it is now? Of course, you would think about it. You remember? It's because of compounding frequency. This is annual compounding, but this is quarterly compounding. With quarterly compounding, what does that mean? Remember, the higher the compounding frequency, the greater the future value. The higher the compounding frequency, the greater the future value. Isn't that right? That's what we saw in effective interest rate, or APY. It's the same 1,000, same 6%, same 5 years, but as the compounding frequency increases, future value gets greater, right? So then you might say, oh, then why isn't future value greater? The future value isn't greater because we have the same future value as the previous scenario. Because our scenario is that your target future value in year 5 is 30,000. Yeah, if the future value isn't greater, then that means we can get to the same result. We can get to the same future value with much smaller APR. Make sense? Mm-hmm.
Yes.
Yeah. This is also the same thing as z equals x times y logic. Actually, what I'm trying to say is x equals z over y, and that, what? That seems very simple, but that is a key to really, that's the, I really, I really value that equation really, really high, because it is like a key to almost everything. Because in the universe, in our world, and in our society, a lot of things are the inverse function. In other words, what is z? Look, so if z equals x times y, right? Okay, in z equals x times y, if this is constant, right? If this is constant, and this is constant, and think about it. If this is constant, right? And if this goes down, this will have to go up. Isn't that right? Does it make sense? On the other hand, if this goes down, if x goes down, y will have to go up. That's the only way z would stay constant, right? But this is not only, but even the theory of relativity is explained very easily by this. I'm not, I'll talk about it later because we don't have time. So now here, next, let's find. So it's already 4:17. It's I always give like more than 1 hour and then hardly take any break. But before we do that, let's try it by here. So here, let's think about it. And do you realize that do you understand that we are talking about the same thing here? It's the same example, right? Do you understand that this one and this one are the same example, right? Isn't that right?
Yes.
Yes, because it's same principle, same future value, same APR, right? And in this case, I just expanded it. I just added R column for R rate, and column for N, so that we would get I get to easily to the quarterly rate, periodic rate, and then by multiplying it by 4, right, I get to APR. But that thing was done in just single formula, and I told you I prefer this because this way it is more it's simpler, and if something goes wrong you can easily fix, right? Think about it, if the machine if you can build an and if you want to break break down an engine, right? There are so many, but think about it. If the engine was built, there are so many things that are linked together, connected together by, cogs and wheels, and, you understand, by cogs and wheels. But, so it's not easy to fix an engine, because to identify the source of the problem, you have to dismantle it. You have to break it down, right? Into but then if the engine is already not one single block, but if it is made of 3 blocks put together, it would be a lot easier to fix, because it's easy to just open up one block, one block, and it's easy to find whether there is something wrong there. One block each like that. Instead of, if it is a one giant big block, you have to really break it down, right? It's more difficult job, right? So that's why I prefer this. So if you do it like this, first we will need to find how many quarters it will take, right, to grow when quarterly rate is like this, the APR is like this, and when principal is like this, and target future value is like this. Then first thing we need to do is to find n, the actual number of compounding. And in our example, is quarterly compounding. So over 5 years, there will be 20 compoundings, right? But we know that because we have the scenario already here. But in this case, we have to assume that we don't know how many years it will take. I mean, if you know how many, first we need to find out how many quarters it will take, because what we are given is the quarterly rate, right? We're given the quarterly rate. This doesn't matter, right? Okay. Even without that, we can do that. Or if annual rate is given, and usually I've been telling you, interest rates are all quoted as annual. So given the interest rate, annual rate, we can find the quarterly rate, and from this we can find how many quarters it will take, right? So all you need to do is simply natural log of future value over, right, over divided by natural log of 1 plus r. You have to use the periodic rate, right? Because we are dealing with, our scenario now is, quarterly scenario. So we have to use the quarterly rate. If our scenario is quarterly rate, quarterly, and if you use like, semi-annual rate or monthly rate, then you are, obviously you're making, you're a nonsense, right? Anybody who is using annual rate when the compounding is quarterly is simply, making a nonsense. You understand? And if the scenario is, annual compounding, but if you're using monthly rate, that's also a nonsense. So think about it. If you have a good sense, right? And a good sense is always, common sense, right? And you can't, you can't miss it. You can't, ruin it. So here, and we know the answer already. It's 20. Let's see if it gives us 20. Yes, it gives us 20, so it checks out. And then, okay, that's 20 quarters. So if we convert it into years, what do you need to do? How do you convert quarters into years? Now, who is there? I thought I saw Hannah a while ago. Is she having also a connection problem? How about you, Christopher? How about you, Christopher? Are you there, Christopher? Sometimes you raise your hand, sometimes you don't at all. And it's almost like, once every hour, you raise your hand. Maricel, are you there? Maricel? Maricel, I think your connection is not that bad now. Maricel, are you there? Okay, Maricel, can you tell me, you can type into a chat box, can you tell me, how do you turn quarters into years? How do you turn quarters into years? Maricel. I'll give you 5 seconds. Divide by 360. No, Why do you divide by 360? And you divide, what does quarter have to do with 360? Quarter means 1/4 of a year. Quarter means literally 1/4 of a year, right? So there are 4 quarters in a year, right? Why do you divide that by 360? That completely makes no sense, right? You divide by 360 when you're converting year into if you're converting days into year, then you divide it by 360. Divide by 12. Why? That's month. I mean, if you divide by 12, I mean, if you do that, that you are converting month into year, right? If you're converting month into year, then you divide it by 12. Think about it. It's 18 months. How many years is 18 months? You divide it by 12 and 1.5, 1 year and a half, right? 1 year and 6 months. Isn't that right? Why 12 is coming up there? Huh? So this is, you're not, this is even, a common sense thing. You're not thinking, you're not using good sense. Think about it. And this is, my question was, how do you convert quarters into years? So how do you convert quarters into year? And Sarah, you raised your hand a while ago. Sarah, can you tell me? Sarah?
Yes, Professor.
Yeah, go ahead. Your connection is very poor, so before you get
I,
disconnected. Yeah, go on.
I should multiply
Mhm.
by 12.
Multiply by 4.
I should multiply by 12. Sorry, Professor, I can't hear you.
Yes, we can't hear you.
Yes, Professor.
I see. I'm sorry. I just accidentally, the mute was, I think accidentally. So how long has it been? Was it like 5 minutes? Has it been 5 minutes or like 2 minutes? How long has it been?
Like
Hmm?
maybe 3 minutes or 4 minutes?
4 minutes. Yeah. I'm sorry. The microphone was accidentally muted. Maybe I, touched it accidentally. Uh, so okay. I'm not gonna because it's so difficult. Um, Look, so I've been telling you, um, there are 4 quarters in a year. So when there are 20 quarters, look, what eight? If there are 8 quarters, what does that mean? 8 quarters, that's 2 years, isn't it right? 8 quarters is like 8 quarters is 2 years, isn't it right?
Yes.
And 12 quarters is 3 years, right? And 16 quarters, 4 years. 20. So what's happening here? You have to divide quarters by 4 to convert it into years. Isn't that right? I mean that's what we have been, look here, in these examples, right? Um, in the previous examples, it's 1 year, 4 quarters, but how many compoundings happen? You in this case you're converting year into quarter. So it's, t times n. In this case, it's 8 years, but semi-annual, right? So how many semesters, right? How many semesters are in 8 years? You multiply this by this, 16 semesters, right? 5 years, and compounding is daily. How many compoundings happen over 5 years? You'll have to multiply, this by this. But if you were to convert this into years, then what, 1,825 days, right? 1,825 days. If you convert it into years, what do you need to? You'll have to divide it by 365. I mean, this is the common sense logic, right? It's mathematical, but it's not that difficult. It's really common sense, right? And for that simple question, nobody was able to give me, that common sense answer. How do you convert quarters into year? You'll have to divide this number of quarters by m, which is the number of quarters in a year, right? 4, right? And that gives you 5. Okay. And I've been telling you, I prefer this model because it's more simple, right? And if something goes wrong, you can easily fix it, because you can fix it either, instead of trying to fix it here, if the source of the problem is here, you can fix it here, or you can fix it here, or you can fix. So now this one it should give us the same result. It will give us 5 years, but think about it. First, we will need to, because compounding is quarterly, right? It's natural log of FV over PV divided by natural log of 1 plus, this is not R, right? You understand? Why? This is APR, and why is that not R? Why is that not the periodic rate? Can anybody tell me? Why is this not R? Anyone tell me?
Because we should divide it by m to give us r.
Yeah, because this problem is not annual compounding, but quarterly compounding, right? And who said that?
It's me, Sarah.
Sarah, okay.
Sarah.
You got another. Sarah or Hannah? Sarah.
Sarah, yes.
Yeah, okay. Another 0.25. Okay. So it's not. I'm sorry. It's not C20. So you'll need to adjust it by compounding frequency, which is in E28, and I cannot click it in because the formula is expanded, so it's covering that E28. So I'll have to just manually type in E28. That's fine. Yeah. But okay, so we are here, and then you might think, oh, we are done. No, we're not done. Why? It will give us 20, because it gave us 20 quarters, right? Isn't that right? It gave us 20 quarters. And why? Because we used quarterly rate. So it gave us 20 quarters, right? So to convert this into years, then what do you need to do? Well, you'll need to make adjustment. So how do you convert 20 quarters into years? What do you need to do? Anybody? We already talked about this. I'm asking you, saying anybody's already, I mean, I already gave the answer already, multiple times. Who typed in some? Please say, Hannah, I'm sorry, I can't, you can't hear me, but my microphone is on. I think it's your connection. Hannah, can you hear me? I'm not muted. Okay, it must be your view. Or your connection.
Professor, we should divide it by 4.
Yes, of course. Is that Sarah? The whole thing?
Yes.
Was that Sarah? Yes, Sarah. This time, I'm not gonna give you extra points because this was already, this was already discussed, many times already. The whole thing. You cannot just put 4 right after E28. The whole thing must be divided by 4, because the whole thing is the result, right? The whole thing is, is 20 quarters. So, but don't say don't divide by, don't enter 4 here. 4 is already here, right? Where is 4? 4 is already in the model.
E28.
28, yes. Enter. There you go. Now it gives you the answer in ears, right? Okay, so this is so that takes care of single cash flow model. Now we are that's 440. This is too bad. So next we got to move on to the multiple cash flow model. What does that mean? What does multiple cash flow model mean? What does it mean? So what we have been doing so far is called single cash flow model. Why? It's called single cash flow model because, let me do this. It's called single cash flow model because it's based on, think about it. I cannot use, this is the thing, right? There's no, Adobe is not Microsoft Office product, so it doesn't allow me to use, there's no pen. There's no pen, but there's no draw function. Think about it. If you think about it, you put in our the model that we have been using so far assumes that you make deposit of 10,000 today, or there's a present value, like principal of 10,000, and 5 years later, with so let's take a look at this example. So here's the principal. When you deposit that 10,000 in the bank, there's a one-time cash outflow. Isn't that right? There is a one-time cash outflow from you. One-time cash outflow from you to the bank. Isn't that right? One-time cash flow, cash outflow. And then 5 years later, APR is like this. 5 years later, you get 30K. And that future value is another one-time cash flow from the bank to you. Isn't that right? This time it is cash inflow for you. Does that make sense? Right? Is that so difficult? So in other words, there was single cash flow, right? Each time, single cash flow. Isn't that right? At time 0. So can everyone hear me?
Yes, Professor.
And so you understand why it's single cash flow model, because there's one time single cash flow from me to the bank, right? From the lender to the borrower. So it's a cash outflow from me, but it's a cash inflow from the bank's perspective, right? And then 5 years later, there will be cash inflow to me from the bank. Make sense? So
Yes.
that's why it's called a single cash flow model. But then now let's think about multiple cash. Multiple cash flow model. Why it's called multiple cash flow model? So here, let's take a look at this example. In this example, what do you see? We're making a $1,000 deposit at the end of every year for the next 5 years. And the interest rate is 20%, right? Then in this case, there are multiple cash flows. Isn't it right? Multiple cash flows. Not just once, but there are multiple cash outflows from me into the bank, right? Of course, at the end, I will get, a single cash flow, cash inflow back to me. But in this case, think about it. If interest rate is 20%, the first deposit of 1,000 will earn interest, 20% interest, 4 times compounded. Right? Makes sense? First deposit will earn interest 4 times compounded. Second deposit will earn interest 3 times compounded. Third deposit will earn interest 2 times, twice only. Fourth deposit will earn interest only once. And the last deposit doesn't earn any interest, right? Because it doesn't stay in the bank even 1 day, right? Actually, technically it's called deposit, but in this case, you just put it there and just take it out, right? Because this is the end of the 5th year. I mean, you don't even put it, you don't even have to put it there. Anyway, you put it there and take it out right away. That's not even still $1,000 is with you because it didn't leave you in the first place, right? But just to meet the regulations, I mean, to earn all this interest accumulated all this time, the first deposit has earned interest accumulated for 4 times. The second one 3 times, 3 years. Third one interest accumulated for 2 years, and so on, right? To meet that requirement, you will have to put it into the bank anyway. So it's like you can think of it as dipping a chip into a dip, whatever, salsa or bin dip or whatever. If you have a chip and you dip it in, you take it, dip it in right away. But if you dip it, there should be some sauce on it, salsa on it, right? But then it's almost like not even dipping. You just touch the barely touch the surface of the dip, and it's. But in this case, calculating the future value, this is a very simplified model. So only 5, payments or 5 deposits. So it's not difficult to calculate the future value of each deposit. Okay, does that make sense? So all you need to do is, just this one. Future value of the first deposit is this. Future value of the second deposit is this. Third one, fourth one. And this is not even future value because you are at the end of year 5, and that's $1,000 at the end of year 5. So it is, just 1,000. So then this type of future value of this type of, multiple deposits is sum of all these numbers, sum of all these future values. That makes sense? Everyone, does that make sense?
Yeah.
Okay. All right, good. So this type of multiple cash flows. This type of multiple cash flows are called annuities. Okay, annuities are basically equal payment or equal deposit. I mean, deposit and payment are basically 2 sides of the same coin. Okay. Normally, so in the formula, we don't call it deposit, we call it payment. Okay, in the formula, it's called payment. And annuity sounds like something annual. No, it's not only annual. It can be quarterly, it can be monthly, it can be daily, it can be weekly, right? It can be at any interval. But the point is, it has to be the payment has to be equal amount, right? It must be equal amount paid or deposited at regular interval, okay? That's annuity. So multiple cash flow model doesn't only refer to annuities, because think about it, there can be an annuity, there can be a multiple cash flow, something like at the end of year 1 you put 1,000, at the end of year 2 it can be 2,000, at the end of year 3 it can be 1,500, at the end of year 4 it can be another 1,000, at the end of year 5 2,000. In other words, the deposit amount or payment amount can be irregular, right? Uneven, right? Uneven. And the interval may be irregular. It doesn't have to be annual. Sometimes it can be 6 months, or sometimes 9 months, sometimes 12 months, sometimes 18 months. It can be all irregular, right? So think about it, multiple cash flow model is a broad concept, because under multiple cash flow model there can be annuities and there can be non-annuities. Non-annuities are the ones that will have multiple payments or deposit, but at uneven amounts, right? Uneven amounts at irregular interval, right? But we're not going to talk about, non-annuities. We'll be only focusing on annuities, right? So this is the future value of annuity, right? Future value of annuity. But you might wonder, okay, what is then future value of annuity subscript D? That's called annuity due, because there are two types of annuities. One is ordinary annuity, and the other one is annuity due. This is ordinary annuity. And in ordinary annuity, what did you notice? Oh, can I not make this deposit at time 0, starting from time 0? Yes, you can do that, but if you make deposit at time 0, then the last deposit, if you make 5 deposits, the last deposit will be here, right? And that case is called annuity due. That case is called annuity due, okay? So the difference between ordinary annuity and annuity due is ordinary annuity assumes the payment, that the payment is made at the end of each period, right? So if you think about it, in ordinary annuity, the last deposit doesn't earn any interest, right? And the first deposit, the oldest deposit, or the maximum number of compounding is n-1. You understand? n-1, because in this case, n-1, 4, right? Because it will be there for, deposit will be there for 4 years, not 5 years. Make sense? Mm-hmm. And this is n-2, n-3, n-4, right? In annuity due, the difference is you make the deposit at the beginning of the year, beginning of each period, right? So in this example, 5,000, 5,000, 5,000, 5 deposits, right? For 5 years. And the first deposit, because it's made at the beginning of the timeline, at time 0, right? If interest rate is 10%, whatever interest rate it may be, it gets compounded 5 times, because it's going to be there at, for 5 years. Second deposit, compounded 4 times. Third deposit, right, 3 times. Fourth deposit, 2 times. Even the last deposit will be there for 1 year, so it's gonna earn interest once. And the future value of annuity would be sum of all these future values. right? So this is the concept, but obviously this is a very extremely simplified model just to make it easier for you to understand. In reality, the annuities, it can be 30 years, and the compounding can be monthly, or even quarterly, monthly, or even daily. I mean, that would be only extreme example, right? Theoretical case, but and then obviously you cannot do this. You cannot put a diagram. You cannot do it like this when you are dealing with like 30-year timeline and monthly payment, right? You cannot do it like this because when are you going to do it? One by one. There will be, if it is monthly, there will be 360 payments over 30 years. So it is ridiculous. You can't do that. So the point is, so you got the idea about the annuities. So we have annuity example. We can't do it today. We'll have to do it tomorrow. But please, you should have read. Oh no, not this one. You should have. This shouldn't be your first time. And if there's future value of annuity, there must be present value of annuity too. So we're gonna get so. Read this, okay? Read this. And we'll get back to this tomorrow, okay? All righty, so that's it for today. Take care, everyone. I will see you guys tomorrow, okay? Signing out.
Have a good day, Professor.
You too, thank you. All right, some babies are crying, I guess.